This week, in our first segment, we welcome Alexander Krizhanovsky, CEO at Tempesta Technologies, to talk about fast and secure web. In our second segment, we welcome Tony Puntanero. He's the community manager at Offensive Security. He's coming on to discuss assembling your first InfoSec home lab. In the security news, the U.S. Air Force slaps googly container tech on yet another war machine. And you can probably tell which news outlet had that title. Rare firmware rootkit discovered targeting diplomats. Hackers exploit Windows error reporting service in a new fileless attack. The HP device manager vulnerabilities could allow full system takeover. Malware exploiting XML RPC vulnerabilities in WordPress. And it's the 10-year anniversary of, you guessed it, Stuxnet. Is your operational technology safe? All that and more on this episode of Paul's Security Weekly.
This is Security Weekly, for security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly. Hackers attack systems that are not patched. You need protection, but virtual patching isn't working. That's why you go patchless. Topia analyzes, prioritizes, and remediates vulnerabilities before they're exploited. Even the 0 days, all from one interface. Security gets better memory defense to complement endpoint strategy while improving overall vulnerability management and compliance. Adopt a hacker's mindset, eliminate vulnerability. Get your 30-day free trial at securityweekly.com/vicarious. Want to be more thorough while also working faster? It doesn't matter if you're on the red or blue team, an augmented reality overlay can enable you to be more thorough and faster at the same time. No glasses, no goggles. Polarity delivers this superpower as an overlay on top of your existing workflow and tools. The free Community Edition connects to the data you care about to overlay the context you need to make informed decisions. Apply for early access today at securityweekly.com/polarity. The question is simple. Have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM.
Long before the FDA warned you about the dangers of Bluetooth-enabled sex toys, his groundbreaking novel about a sentient vibrator that worked its way into your heart and found true love rocked us all. It's a man, a plan, it's Paul-a-mania.
Welcome, everyone, to Paul's Security Weekly. I think Dr. Doug White used to be a writer for The Simpsons Show. This episode is number 669, recorded on October 8th, 2020, right here in G-Unit Studios in Rhode Island. To my left, of course, is Dr. Doug White. Welcome, Dr. Doug.
I'm back. They let me back on the air.
We did. I mean, we're in the new digs. We moved some more stuff around.
I know.
There's a couple more upgrades coming.
It's beautiful.
Yeah.
Beautiful, man. It's beautiful.
Well, you see the two-shot now has got the bar scrolling across the screen because of, well, the NTSC thing.
It's super cool. We got new microphone.
Frame rate? I think the frame rate, right, causes those bars if you look at the thing.
Yeah, no, it's the frequency rate.
Frequency rate, yeah.
It's the yes, that's why you're getting
refresh rate. Johnny has its refresh rate.
Refresh, yeah.
Yes. Yeah, but it's still
slightly out of sync.
Yeah, looking really cool. It's awesome. Mr. Lee Neely is on the lines remotely. Lee, welcome.
Good to be here from across the country, and hopefully not too horrible a resolution. My laptop's being a little bit of a jerk today. Looking forward to some fun.
It's a good thing you got a full glass of apple juice, though, Lee.
Oh, yes. The finest 1792 apple juice.
There you go. 1792 vintage, huh? Those are some old apples.
Yeah.
Mr. Tyler Robinson.
Well-aged.
Well-aged. Mr. Tyler Robinson is here with us. Tyler, welcome.
Those are the best apples. I think I like that 1792 better than anything.
Yes.
It's one of my favorites.
One of your favorite apple juices out there, huh?
Yep. I wish they put those in the little boxes so you could take them with you everywhere.
Yes. Very nice. Well, let's see. Quick announcement. Security Weekly, in partnership with the Cyber Risk Alliance, is excited to present Security Weekly Unlocked on December 10th, 2020, the inaugural edition of Security Weekly Unlocked, which is also spelled wrong. Inaugural is spelled wrong on the teleprompter. Also celebrates Security Weekly's 15th anniversary. Registration and call for speakers is now open. So if you would like to speak, please, we need you to come speak at the event. We would love to have all of you, or at least have a lot more of you to choose from. Although we've gotten quite a few submissions recently, which I'm very happy about. You can also register for the event as well, which I hope pretty soon will also give you the invite to our Discord channel. But for all things Security Weekly's first official virtual conference, you can go to securityweekly.com/unlocked. Make sure you go there, submit to talk. Free to register. We're not charging for this event. It is completely free. Let's see. Our guest for this segment is Alexander. I won't butcher your last name again. Alexander is the CEO of Tempesta Technologies and is the architect of Tempesta FW, a high-performance open-source Linux application delivery controller. He designed the core architecture of a web application firewall mentioned in the Gartner Magic Quadrant and MariaDB temporal data tables. Alexander, welcome to the show.
Hi, everyone. Hi. Thank you for having me, and I'm really glad to be on the Security Weekly show. Hi.
Alexander, it's nice to have you. How do you pronounce your last name, which I forgot to ask you?
It's Russian. In Russian, it's Krizhanovsky, but in English, usually Krizhanovsky.
Krizhanovsky. Someday I'll get it. I'll work on it. We'll work on it.
Okay, don't worry. It's a long family.
Alex, how did you get your start in information security?
I guess Joe contacted me in LinkedIn, and I watched several your episodes. I watched the episode about HP security, about HP security headers, and the recent previous issue about Nginx RTMP.
Oh, I'm sorry. How did you get started in the field of security? Like, did you start your career?
Wow, it's a long story. I started as a junior, as a student in one of the Russian companies. I started in VPN kernel development. That time I was working on crypto stuff, cryptography. After that, I moved to security proxies to another company. After that, I moved to the Linux kernel. And when I started Tempesta Technologies, we quickly go into high-performance networking stuff. Mm-hmm. And one of the networking stuff is security applications. So usually network security stuff like VPN, security proxies like web application firewalls, and so on face performance issues. So we balance somewhere between security and performance stuff.
That's awesome. So, Alex, tell us about the product that you've built, which is primarily open source, right? And, striking that balance in our previous conversations, right? Striking that balance between performance and security is often very challenging. But I believe you've come up with a very, very novel solution that allows for both an application to be very performant and secure at the same time.
Yes. The story begins in 2013. That time we had a request from Positive Technologies company to develop a web application firewall. And that's not a secret, but we start usually web application firewalls are modules on top of some open source HTTP proxies like Nginx, HA proxy, whatever. The security models do deep analyzing of HTTP traffic. And that time when we started the project, we realized that while open source proxies like HP, like Nginx or HA proxy very good in proxying traffic, but they never be designed as high-performance filters of malicious traffic. It means that if they're good at processing normal HTTP requests, they never considered, for example, to fight against asymmetric DDoS attacks like heavy TLS handshakes, about slow HTTP requests, and so on. Surely, Nginx and other proxies have some features to be resistant against such kind of attacks. They never be designed as a firewall. So that time we like it was a aha moment, like this firewall in the Linux kernel and netfilter, and this application layer HTTP servers. So we thought, why not to continue CP/IP stack with HTTPS, and we came to the hybrid of HTTP accelerator and the firewall. We continued Linux TCP/IP stack with HTTPS, and now we work just like netfilter in context of the TCP/IP stack of the Linux operating system, and we able to filter malicious traffic efficiently, as well as serve normal traffic at high speeds.
Were you able to bring the code like closer to the kernel, as opposed to being a more like higher level application like Nginx having to do a lot more things? Is that part of the performance increase?
Well, I can show you the slides, but the story is that well, if we run some simple DDoS attack, say HTTP flood against Nginx, and we run Linux PF2 to see what's the bottleneck of Nginx on the under the attack, we will see that Nginx is well optimized software. It means that it has so-named flat profile. It means that the most hotspot function is not so dramatically different from another functions. And optimizing the most hotspot will bring us maybe 1 or 2% of additional performance.
Mm-hmm.
So it basically does not make much sense to move Nginx or some user space proxy into the kernel, or from the other side to move say the Linux TCP/IP stack, or usually FreeBSD TCP/IP stack into the user space,
Mm-hmm.
say using DPDK closer to application. We should really eliminate context switches and data copies, but the architecture problems are still there. So in Tempesta, we developed every piece of software from scratch. We developed a very high-performance HTTP parser. We embed security checks into the parser. We developed TLS implementations. Well, we started from embed TLS, but it was fully reworked. We optimized it for more than 40 times in performance, and now we can beat OpenSSL and Nginx in several times.
So you basically just rewrote everything, and in my experience, when you do that kind of performance testing, right, it's usually not one like major architectural change that all of a sudden just makes everything run faster, right? It's a series of smaller architectural and design decisions correctly implemented that gives you more performance. And it sounds like, Alexander, that's what you've done to achieve what you have.
Today is 2020, and it's maybe not a good time to write one more HTTP server or one more TLS implementation from scratch. However, we write everything from scratch, and this is because we didn't see any opportunity to optimize significantly Nginx performance or OpenSSL performance. We had to develop or host this code from scratch.
That's amazing. And Alex, you had some slides to kind of show us what the architecture and some of this looks like.
Yeah, absolutely. So let me share the screen. Okay. Okay. Here we go. I already talked about the history that we started with positive technologies that exactly web application firewall mentioned in the Gartner Magic Quadrant. I said that it's Tempesta FW is built into the Linux TCP IP stack. Application delivery controller, it's a clear thing. It's just a HP proxy with advanced security features like application and volumetric DDoS protection and web security stuff. And one of the scenarios for Tempesta FW, while it's the Linux kernel model, we cannot run all the checks which enterprise WAFs can do. So we're supposed to be installed as a WAF accelerator. In this scenario, we can offload TLS handshakes, we can offload TLS normal workload, we can filter out DDoS attacks, and we can load balance workload among servers with static data or dynamic logic servers. And surely there's no sense to place web application firewalls in front of static data. There's nothing to hack after all. So usually WAFs place it in front of dynamic logic. And having that, typical WAFs aren't so fast. It's probably safe to say that typical WAF deliver about 50 megabits per second from a CPU core. It's not so fast. So if you have a heavily loaded web resource, then typically you need several WAFs, several instances. And Tempesta can load balance the traffic among WAFs, offload some security checks from the WAFs, and the most importantly, it can offload the HTTP blocking rules from the WAFs. And also we have a web cache. Web cache is very fast. We made a benchmark on the cheapest Xeon hardware, and we delivered about 1.8 million requests per second from a 4-core CPU. It means that most of HTTP flows can be just serviced from the web cache. If we consider how to filter out HTTP requests with a particular host header and port, then it's not easy to do with IPtables, strings, or BPF, XZP, and so on, because the tools work on packet ranges, and they don't know anything about HTTP headers. The right way at the moment is to use network intrusion prevention systems like Suricata, and Suricata can work with multi-layer firewall rules. There are some topics why we didn't go with HTTP accelerators. There are data copying among the Linux kernel and the application server syscalls and data copies, not fast HTTP state machines and strings processing. We also made changes to network I/O. How do we handle? And TLS traffic is also not properly optimized. And of course, web cache. Recently, we had presented our Tempesta TLS at the NetDev conference. It's 0x14. Basically, TLS performance is crucial for application delivery controllers like F5 or Fortinet. If you list the datasheet from the vendors, you typically see TLS handshake. How do they fast? This is a reference to YouTube video from F5 engineer comparing Nginx on top of DPDK with F5. And F5 about 50% faster than the Nginx. Let me show the little demo about Tempesta TLS and about how fast the current implementation. So the first thing which I want to show is that Tempesta can be managed just like any usual user space daemon. Let me start it. Here we go. So now we see Tempesta in SS. I forgot to start Nginx. Okay, so I guess we're good. At the moment, let me test TLS handshakes for Nginx. This benchmark tool also written by our team. It's also open source. What it does is just to establish a lot of TLS handshakes and drop the connections. This data for...
Sorry, Alex. So
sure.
The performance testing tool, you developed, your team and yourself developed that tool, and it's open source. So any of us can use this tool to test the performance of our TLS-based applications.
Yeah, I can show the GitHub. Let me show it.
It's actually pretty timely with a project I've got coming up.
Okay, so we can do this later.
Okay, yeah, that's
now
fine.
let me start for the benchmark against the Tempesta against the Nginx. Just 10 seconds. So Nginx shows average less than 1,000 handshakes per second. For Tempesta, we had almost twice faster. And if we run this full handshakes, but usually people use only abbreviated handshakes, TLS handshakes, because of returning users. So this one with TLS tickets on, we test the abbreviated handshakes, and for now we see the number for Nginx, a bit more than 1,000. The difference between the numbers so low is because I'm running on my virtual machine. For Tempesta, we see 4,000. It's almost 4 times faster than Nginx. So even having the normal traffic of returning users, you still benefit from higher performance. This is a benefit of our self-developed handshakes. We also have advanced filtering abilities built into our HTTP parser, so we can filter injection attacks. We have a JavaScript challenge. Well, I'm not sure about the time frame, so should I continue with my presentation and demo, or you have some questions?
No, continue.
Okay. So in Tempesta, we implemented JavaScript challenge. This is very close to what you see when you visit some web resource protected by Encapsula or Cloudflare. Like Cloudflare or Encapsula is checking your browser. So let's see how does it work with Tempesta. First of all, let me check the configuration file and see it. So in Tempesta, we configure Tempesta just like Nginx or other HTTP servers. So we have a configuration file for sticky cookie. We use sticky cookie in JS challenge. This cryptography protected data about timestamp and the client identification numbers. Next, we have HTTP tables rules. This application layer firewall integrated with IPtables. If we have time, I will show how does it work. I guess everything is ready. So let's restart Tempesta. And now I have a browser. I clear data. First, I check, JavaScript is enabled. I disable it. And this our website hosted on Nginx, and this Tempesta front of Nginx. Let's see what Tempesta does. So this JavaScript switch it off. This our custom page, which you can also. This is just a basic template, and you can change in any way you want to make it more attractive for the users. But basically, this is what Encapsula shows you or Cloudflare. So I enabled my JavaScript in browser and just reloaded, and here we go. We have our website hosted. In log file, we see that Tempesta worked on JavaScript. So let's back to the presentation. The unique feature for Tempesta is that while we have a similar model for Nginx, however, it's still not in the main tree of the Nginx. In Tempesta, we have a specific time frame. This in green. So when client goes to Tempesta, Tempesta prepares a sticky cookie value with encoded time frame given for to the user and user ID, IP, user agent, and so on. The data is encrypted and signed, so we don't need to keep the state on Tempesta side, and we just pass it to the client. The mechanism works just like sync cookies. JavaScript starts, and the thing is that redirect produced by the JavaScript can be done only in a very narrow time window. If a client sends the request before the time frame begins, then Tempesta blocks such a client. So the thing is that even if your DDoS bot agents are able to hardcode JavaScript challenge, like not to execute JavaScript, but just try the redirection, they still have to slow down to fit into the time frame. And we actually we do what we need. We slow the botnet down, and we fight against the DDoS attacks. Any questions, by the way, so far?
No, that piece is really interesting, because what that means is I can't just script a bot to blast out a bunch of requests, right? I have to. What you're saying is basically fit within a time window that would make it more match what a user would do and not a bot, correct?
Yeah, absolutely.
Is that time window user configurable?
Pardon?
Is the time window user configurable?
Yes, absolutely. This configuration for the stuff, this cookie name, this how many times we can pass requests without cookies, and this HTTP response code, which is generated for the JS, and this delay range, delay limit, and delay minimum. There are 3 time frames which are control the time window, how wide it is, and when it starts, and what's the maximum deviation from the time. Because we actually cannot be too strict in this limitation, because we realize that there are different appliances, there are slow devices, there are connections, very slow internet connections, and so on. But everything is tunable and configurable.
Sweet.
Okay. The next feature which I want to show, it's a multi-layer firewall. Actually, the thing about Tempesta is that while it looks like application layer HTTP proxy, like you can still use TCP dump, SS, nested, and so on, it's very fast. And it's well integrated with the Linux infrastructure. In Linux, we have advanced firewall, nftables. And nftables provides the mark set. So probably it's easier to show how the things work. So let me comment the JavaScript. We don't need it anymore. And now let's try to configure integration of IPtables and Tempesta. What we have now? When Tempesta receives an HTTP request, it checks first against the mark value from IPtables, and if it's equal to 1, we go to L7 rules chain. It's the HTTP chains are just like chains in IPtables, and in this chain we check the value of referer header, and if it matches against the wildcard, against the bad host, then we block the traffic. Otherwise, we pass the traffic. The syntax is a bit different, but the idea is just like IPtables. And now let's see what the mark from IPtables. So I restart Tempesta. Actually, you don't need to restart it. Most of security features can be switched on and switched off by just on zero downtime configuration. It's somewhere I didn't want to restart. Let me see. It should be good for now. Okay. That's the problem. The thing is about virtual host configuration. So let's start. So now we're good. Okay, let's add IPtables rule. This rule against IP address. This IP address is the address of my host machine. At the moment, I'm inside the virtual machine, and we set the mark 1 for each IP packet from this source address. So now we're good, and we're ready to filter traffic by IP address and HTTP header. So first of all, let's try to request the page from localhost inside the virtual machine, and I use the bad host value. Now who receives the packet, and it means that while host header is in HTTP table, it's not filtered. However, if I try to do the same from my host machine, who doesn't receive any response. If I change a little bit the referer, then here we go, we get the whole response. So we really wanted to provide something like suricata logic and filtration abilities for HTTP proxies, and do this in a very efficient way. And this is what IPtables is. I'm almost finished. The last thing I wanted to mention is that we compared our performance against DPDK, the best and the fastest DPDK-based HTTP servers. It's like a CStar. They use very simple and very fast TCP implementation in user space. And on 4 CPU cores, they show the same, about like 1.6, I guess, millions requests per second. So performance is comparable to Tempesta FW. So probably I'm done with the presentation and the demo. Maybe some questions.
Alex,
I was wondering.
Yeah.
Go ahead, Lee.
I was wondering how many rules can you put in there before it starts slowing down because it just takes so long to parse them?
Well, not so much. At the moment, we analyze them in just like IPtables. We don't do any optimization here. We have feature requests to improve it in next releases. But at the moment, we definitely slow down as you grow the filtration rules, number of filtration rules.
How many?
Where's the sweet spot?
Yeah, that's my question, Lee. How many rules can you add before you start to see any significant performance?
Well,
decrease?
we didn't do such performance benchmark yet.
Gotcha.
We know that current implementation isn't the most efficient which is possible. We improve it, but in next releases.
Gotcha. On the last slide that you had up, Alexander, you had something about eBPF.
eBPF. In one of the slides, I mean that, you can filter traffic using eBPF, for example, right? Or XDP. Basically, the same language, but different layers of filtration.
Yep.
With Tempesta, you can use eBPF and XDP. And we have a task to use XDP filter to fight against volumetric attacks. And the thing is that XDP and eBPF perfectly works together with Tempesta FW. And the point is that you cannot use XDP or eBPF with DPDK-based applications.
Alex, when you get into the rules, like how complex can your rule filtering system be? Like, is it basically like a basic regex in helping to prevent DDoS attacks? Is that kind of the use case, or like how much more advanced can you get in your rule base?
At the moment, we're in alpha state. So we implemented very basic rules. So using IPtables, you not only can filter traffic, but also distribute it among virtual hosts. Probably you saw in my configuration that I have a virtual host. We can have more virtual hosts and distribute traffic among them. This is a flexible load balancing solutions. However, we have tasks in our GitHub to develop filtration logic further, but we at the moment we switch from DDoS prevention logic to WAF logic to TLS to some basic HTTP stuff and so on. So we constantly back and switch from one model to another. And you asked about regular expression, and we do have a task to use multi-pattern regular expressions for IPtables.
Gotcha.
Is the placement of this system, is it more like a proxy, so it's sitting out at the front of your network, or is it in segments, or is it for every individual server that you have?
It's our dream is to provide an open source alternative to hardware appliances like F5, Big IP, or Fortinet ADC. Okay. They are hardware appliances which relies on the edge. Sometimes before your front end servers. From the other side, using Tempesta FW, you can build your own filtration networks. The modern clouds provide you floating IPs like DigitalOcean, and you can purchase a lot of virtual machines, or, for example, say you can use one virtual machine in one data center, another in another data center, and use some floating IPs, say 10 floating IPs on each of the virtual machines. Use GeoDNS. So now we have a traffic distribution, and once you have more traffic, you can quickly replicate the virtual machines, distribute your floating IPs, and here we go. We have a filtration CDN like Cloudflare provides. So from the other point, we can allow individuals and companies to build their own filtration content delivery networks quickly using public clouds. And in this case, you fully control your traffic, you don't provide your private keys and certificates to third parties, and you control your client's traffic on your instances.
Do you see this getting to a point where you're building a constantly updated rule set for this that's getting pushed out, or is this something I'm going to have to maintain on my end all the time?
Do you mean something like rules updates like mod security provides?
I'm thinking
like arachnids.
Well,
to go way back in the Wayback Machine.
Well, yeah, I'm thinking of that, but I'm also thinking about like, MSISEC pushes out a huge list of IPs that we need to block and all these kind of things.
Yeah,
so,
I mean that's a really good use case.
I mean,
for this.
yeah. So if I had
this.
this running and it's super fast, and I just push MSISEC blacklists in there every day. I mean, obviously I could do that myself since it's open source, but I was just kind of trying to see where your
There's
vision
commercial offerings for that too.
Exactly.
But Alex, what you've built, I bet you would rival some of the performance of some of the commercial offerings.
Yeah, yes. By the way, thank you for good idea. I actually never thought about the updated rules, but it definitely is a good point for commercial support of Tempesta solutions.
Yeah, that's a really good use case.
At the moment, we don't have such stuff because at the moment we focus to reach our release, our J with Tempesta. At the moment we are in alpha, so we are looking for pilot projects and the right market fit for our features and the solution in general.
That's just something it seems like a lot of people are looking for, is the ability to see that just on the fly. When a bad thing gets announced, I want it in there right now. I want it blocked. I don't want to have to worry about it. And so that I think that with it being open source, obviously I could write it, I could code it myself. But I mean that's definitely a good. I think a good thing to add to your product that would get a lot of people who are looking for these very kind of things really interested.
Agreed.
Yeah.
So it's a great kind of segue into this is open source. You're also doing, it sounds like, some custom like commercial work too. So what are you looking for in terms of engagement, right? Are you looking for people to go, hey, we'd like to license your technology, we'd like to for you to build this for us, right? And you're also looking for feedback from the open source community, correct?
Yeah. Actually, we are a custom software development company, so we earn money, but by development custom software solutions, and we put all our money to development the product. So at the moment, Tempesta doesn't provide us any revenue at this point. Probably we'll move to the whole fully product business in future, but not at the moment. Yes, at the moment we consider OEM solutions, and we discuss with some ADC vendors, OEM versions of Tempesta. Usually people use Nginx, HA proxy, and I forgot the fork of HA proxy employing very fast web cache. But there's a third option of usual implementation for hardware ADCs.
Alex, how in being really focused on performance, how do you and your team not fall into the trap of introducing a security vulnerability, especially when you're dealing with TLS, when you're trying to operate fast, right? A shortcut in TLS, we've seen it in the past, right, can lead to a security vulnerability. So what do you and your team to make sure that you're not introducing some type of security bug?
Well, I guess that is a very sophisticated question, right? Because nobody knows and nobody can be sure that he or she doesn't introduce any new vulnerabilities. However, during work on our paper for the NetDev or last NetDev conference, where we presented Tempesta TLS performance stuff, we first of all, we used Mbed TLS as a base for our code. However, Mbed TLS was almost fully revoked. So we also had a look on OpenSSL implementation, the WolfSSL implementation. And actually, we reported the vulnerability about side channel attacks, vulnerability for WolfSSL library. So everyone makes vulnerability issues. So probably we also introduced some of them. And actually, in our current roadmap, when we reach GA or maybe beta, we are going to purchase third-party security analysis for our code, not only for TLS, but also HTTP layer, because it's also very, very crucial. At the moment, we are going to... Yeah?
I was going to say, it seems like you're solving so many neat problems. How do you choose which ones to work on?
That's a hard question. I also said because that typically we just go our to-do list with different tasks. So we're switching between TLS to HTTP to develop our HTTP filtration logic, to develop our WAF logic, and so on. And actually, we're constantly looking for talented software developers to help us to develop more and more features. And this is the right question. Because we do very specific stuff, like there's no TLS libraries in the kernel. There's no HTTP stuff in the kernel. There's no Quick or HTTP3 in the kernel. So we have to do everything on our own. From time to time, we use already open source, but we have to tightly modify them to fit performance needs and to fit the kernel code itself, because the kernel also restricts how the code can be written and work.
Alexander, this is great stuff. I am so happy you had the chance to come on the show and share with us and our audience this great information. Where can folks learn more? What's the website?
Tempesta-tech.com.
Outstanding. Alexander, thank you so... Oh, sorry, go ahead. Yeah. Closing thoughts?
This GitHub, the repository is hosted on GitHub, or you can just type Tempesta FW in Google, and you see our website with a reference to GitHub repo or GitHub itself. So.
Awesome. Alexander, thank you so much for appearing on Pulse Security Weekly.
Thank you very much for having me. I was very happy to be on Security Weekly.
Well, with that, we'll take a short break, come back with Tony from Offensive Security. Stay tuned.